In the quiet of the Martian night, when the thin atmosphere lets the stars burn with an intensity unknown to Earth, a peculiar shadow crossed the red world's gaze. Against the darkness, a visitor shimmered 3I Atlas, a body not born of our sun, a fragment of the interstellar deep, now caught for a fleeting instant in the mechanical eye of Mars's orbiters. The first images that arrived were not simply photographs, they were riddles etched in light. At first glance, they resembled any cometary speck, a pale blot, uncertain against a backdrop of stars. But when processed, frame by frame, the light did not behave. Its pulse was erratic, like the heartbeat of a creature unfamiliar with the rhythm of this solar system. Instruments circling Mars had been directed toward the heavens, expecting to find only silence and dust. Instead, their detectors found reflections, sharp glints at strange intervals, as though surfaces were turning deliberately toward the Sunday. Shadows too long for the object's presumed size stretched across the imaging field, suggesting structures, not randomness. And within the thermal maps, heat seemed to rise and fall out of cadence with the sunlight, as though the body obeyed laws that our physics had not yet written. Mars had become the second great eye of humanity. From Earth, we had seen 3I Atlas as a faint intruder, slipping in and out of awareness, a whisper against the galactic hum. But from Mars, closer in geometry, the visitor looked stranger, clearer, more unsettling. The planet's orbit had placed it in perfect position to watch the interstellar body's trajectory unfold, and in that vantage, something unexpected was revealed. It was not simply a rock, nor quite a comet, nor entirely an asteroid. It was something else, an interloper carrying its own geometry, its own behavior, its own message from the spaces between stars. With each pixel recorded, with each glint unraveling into data, Mars did not just see a fragment of the void. It saw a question sharp enough to pierce the foundations of planetary science, a question vast enough to whisper of other worlds, other times, and perhaps other minds. The red world stared into the dark, and the dark, through 3I Atlas, seemed to stare back. The story of 3I Atlas does not begin on Mars, though it found a peculiar clarity there. Its earliest traces belong to the patient, sleepless nights of astronomers scanning the skies from Earth. Telescopes designed not for wonder, but for watchfulness, swept through the heavens in search of subtle motions, small, shifting specks among countless stars. When Atlas, the asteroid terrestrial impact last alert system, caught the faint streak, it seemed at first unremarkable, a distant wanderer catalogued among thousands of similar visitors. But in time, its path betrayed it. The orbit could not be closed. Its velocity, plotted carefully against the sun's pull, was not the signature of a captive. Like Oumuamua before it, like Borisov after, 3I Atlas moved on a hyperbolic arc, an interstellar trajectory, not native to this system. It did not belong to the Sunday, it belonged to the galaxy. The announcement rippled through observatories across the world. Once again, Earth had been brushed by an object from outside. Once again, astronomers were offered a fleeting chance to study matter that had formed under alien suns. Yet this time, there was something more. The timing of its geometry promised an extraordinary gift. Mars, moving into position along its orbit, would see the visitor not as Earth had distant, blurred, nearly lost in the noise, but from a far more advantageous angle. The moment of recognition carried a weight of history. Generations of astronomers had labored under the assumption that interstellar objects would remain theoretical, glimpsed only in equations. The stars seemed too vast, the gulfs between systems too wide for such wanderers to appear. And yet, within the span of a human lifetime, 3 had revealed themselves. This one, 3I Atlas, became more than another entry in the celestial ledger. It became a stage for cooperation, Earth-based telescopes passing coordinates to Mars orbiters, data relayed through the vacuum, a shared pursuit across two worlds. The people behind this discovery were not mythic figures, but the quiet workers of science, graduate students scanning digital images pixel by pixel, data analysts feeding coordinates into orbital models, engineers calibrating detectors that had no expectation of such a task. And yet, they had opened a window onto the interstellar deep. Their tools, meant for planetary defense, had instead caught the trace of a stranger. This was the discovery phase when wonder first emerges from the noise of numbers. What began as a faint anomaly became a message. Something from beyond the heliopause had brushed near enough for us to see. And in that discovery, a new chapter began not on Earth this time, but on Mars, where cameras and spectrometers turned their gaze outward, waiting for a story written in alien light. Mars was not chosen by accident. Its skies, thin and unburdened by the dense blue haze of Earth, grant a clarity that is almost cruel. The planet is a high desert world, a frozen plateau adrift in space, and from its orbiters the void appears sharper, colder, more absolute. When 3I Atlas entered the geometry of Mars's horizon, scientists realized the red planet could serve as a second observatory, one far removed from Earth's distortions, one poised to give us another angle on a visitor from the deep. The decision was strategic. Earth's telescopes, bound by the cycles of weather and atmosphere, can lose precious nights to clouds. Mars, by contrast, carries in orbit a flotilla of machines, HiRISE aboard Mars Reconnaissance Orbiter, CTX with its broad sweeps, Marcy with its daily climate surveys, and Themis mapping thermal patterns. Added to these, the atmospheric explorers Nomad and ACS aboard TGO, and the Maven mission tuned to plasma and ion interactions. Individually, each was built for Mars. Together, they became an unplanned interstellar observatory. Why Mars? Geometry is destiny. As 3I Atlas curved across its solar trajectory, Earth was aligned awkwardly, viewing the object against crowded star fields, distances stretching the limits of resolution. Mars, however, stood at a favorable angle, just offset enough that its orbiters could see details. Earth could not phase angles sharper, light scattering richer, thermal contrasts more distinct. From this position, Mars did not simply watch an object pass. It caught the body in a pose Earth's instruments could never capture. The choice of Mars was also philosophical. To gaze from another world is to break the singularity of Earth's viewpoint, to extend human vision outward in a tangible way. For centuries, humanity's knowledge of the cosmos has been filtered through a single vantage. But here, in this moment, two planets worked in tandem, one alive with minds, the other alive with machines, to interrogate an interstellar ghost. It was a symphony of geometry and technology, an act of planetary cooperation without borders. And when the first datasets began to flow packets of light curves, thermal maps, spectral lines, they carried not only measurements, but the weight of expectation. Mars had been chosen because the universe had arranged its orbit to be witness. Its machinery, built for another purpose, had become our eye on the unknown. In its silence, Mars had agreed to testify. The imaging campaign that followed was not the work of a single instrument, but a tapestry woven from many eyes in orbit. Mars Reconnaissance Orbiter's HiRISE camera, designed to peer into gullies and dune fields, was commanded to focus on a target far smaller than a crater, far more elusive than dust storms. Its resolution, ordinarily reserved for the geography of Mars itself, turned outward, measuring the faint pinprick of a star-like wanderer. Beside it, CTX provided a wider view, its broader sweeps capturing background stars that anchored astrometry. Marcy, spinning its lens across the whole planet each day, contributed contextual data, ensuring the spacecraft knew exactly what the sky was doing when the frames were captured. But the visible spectrum was only one voice in the chorus. Themis, the thermal emission imaging system, opened its mid-infrared eyes to follow the ebb and rise of surface temperatures on 3I Atlas. A world of stone cools one way, a fragile veil of dust another, a sheet-like structure yet another. From these curves, scientists could read the material character of the visitor as one reads the fading warmth of a fire's embers. Meanwhile, the ExoMars Trace Gas Orbiter carried NOMAD and ACS, spectrometers designed to search for Martian methane. These instruments, turned briefly toward the interloper, captured absorption lines that hinted at what gases, if any, surrounded it. Even MAVEN, the spacecraft dedicated to understanding Mars's atmospheric escape, found itself listening to the faint plasma signature stirred as solar wind washed over 3I Atlas. This was no accident of improvisation. It was orchestration. Commands were written, checked, and uploaded across agencies, ensuring each orbit carried its instruments into position, aligning exposures with the predicted arc of the object. It was a ballet of precision, spacecraft hurtling through Mars's sky, timed so their instruments would open their shutters in unison, catching photons that had left the interstellar traveler moments before. For the first time in history, an interstellar body was studied not from Earth alone but from the skies of another world. The cameras, the spectrometers, the detectors all were blades in a single instrument, carved from different purposes, fused now into one. They were an orchestra, and 3I Atlas the score. What they revealed in the opening measures would astonish even those who had planned the performance. The first streams of data appeared ordinary enough, a light curve plotted against time, brightness measured in precise intervals, just as thousands of comets and asteroids had been charted before. Yet, as the hours passed, the lines refused the simple shapes astronomers expected. Where a cometary nucleus should have shown a predictable rotation brightening and fading with the turning of a sunlit face 3I Atlas wrote a jagged script. Its light curve was fractured, sharp peaks spiking between uneven valleys, like a restless pulse recorded on alien paper. What the Mars orbiters captured was more than noise. Patterns repeated, but never fully closed. Spikes appeared at strange intervals, suggesting not a single rotation but a body tumbling chaotically, out of balance, unwilling to settle into a rhythm. This in itself was unsettling, but the brightness variations held another secret: sudden bursts of intensity, brief flares that could not be explained by rotation alone. It was as if the object were catching the sun at odd angles, flashing mirrors to the void. Astronomers debated at once. Were these reflections from jagged planes, fractured surfaces polished by interstellar travel, or did they hint at something stranger? Plate, like shards, glints of thin material behaving not as rock but as structure. The first shock lay not in the fact of variability, many small bodies flicker with rotation, but in the violence of the fluctuations, too extreme for anything so small and so distant. To test the data, Earth-based telescopes attempted confirmation, yet their light curves, blurred by atmosphere and distance, showed only the broadest strokes. Mars, with its proximity and clarity, was the one revealing the truth. 3I Atlas was not rotating like a stone. It was thrashing, flickering, speaking in bursts of brightness no model could easily absorb. The realization spread like a low tremor through the scientific community. The first light curve, meant as a baseline, had delivered instead the first fracture in certainty. If the body could not spin as expected, what else might it defy? Each spike on the graph was a question mark, each flare a whisper of geometry unseen. In the silence of Mars' orbit, the first shock had arrived not through drama, but through a simple plot of brightness against time, a plot that refused to obey. From the Lightcurves' erratic script, scientists expected at least one familiar companion, the faint haze of gas and dust, the trademark of a cometary visitor. Yet the Mars instruments saw nothing. No coma spread outward, no tail unfurled behind. And still, the orbit was drifting, its path curving in ways that gravity alone could not explain. The numbers spoke with unsettling clarity. Precise astrometry, stitched together from high-rise images and ground-based follow-ups, showed that 3I Atlas was accelerating slightly, nudged off its predicted course. This was the same puzzle Oumuamua had offered years before, a push without a visible cause. Comets, when warmed by sunlight, shed volatiles that act like natural thrusters, expelling vapor and dust that impart gentle acceleration. But here, under the red world's scrutiny, no such veil appeared. The object was stark, silent, bare. The paradox deepened with every pass. Mars's spectrometers, tuned to detect even the faintest traces of CO2 or water vapor in its own sky, saw none around the interloper. Themis thermal readings showed no excess warmth that could betray outgassing jets. Maven's plasma sensors found disturbances, but they were too faint, too erratic, to explain a steady thrust. The acceleration remained a signature written into orbital elements, undeniable, insistent. Some proposed subtle jets, invisible to the cameras, composed of supervolatiles that escaped detection. Others whispered of exotic physics, of radiation pressure, coupling with structures too thin for ordinary rock. But beneath the theories lay the core disquiet. Here was an object behaving as though alive with forces, yet presenting the still face of a barren shard. Mars had revealed what Earth could not. From Earth, the anomalies might have been dismissed as measurement error, lost in the haze of distance. From Mars, the data was undeniable. The trajectory bent, the coma did not appear. In that contradiction lived the heart of the mystery, an acceleration without a cause, a motion without a messenger, a secret carried in silence across the solar wind. The observers had asked for clarity. Instead, the red planet handed them paradox. As the days unfolded, the orbiters around Mars returned something even stranger than erratic accelerations. In the hours near local dusk, when sunlight grazed the visitor at shallow angles, HiRISE and CTX began to record flashes, thin, needle-like glints, brief as the blink of a star. They did not scatter randomly. They repeated with unsettling consistency, as though the object carried facets turning toward the sun like a mirror array. These were not the broad, diffuse brightenings of dust reflecting light. They were razor-sharp peaks, appearing and vanishing in fractions of a second. The light was polarized, suggesting reflection from smooth surfaces, rare among natural small bodies. Each glint appeared at nearly the same rotational phase, as though part of a recurring geometry. The implications were unsettling. Natural shards can glint, yes, ice crystals, fractured planes, exposed minerals polished by eons of travel. But the repetition spoke of symmetry, of planes angled just so, like fragments of glass. On Earth, some scientists whispered of panels, sails, or structures too thin to survive ordinary planetary formation. Others counseled caution. The cosmos has often deceived with mimicry, and nature is not obliged to conform to human expectation. Yet the Glints refused dismissal. Models run against Mars's phase angles showed that a long slab-like body could produce them, or else a structure riddled with flat concavities. If so, the visitor was less a spheroid and more a shard, a geometry of extremes. The Martian sky had, without intent, offered the perfect backdrop: thin air, clear horizons, an observatory above the dust. Against that stark canvas, the object revealed its flashing secret. Each spike of light carved deeper into the mystery, carrying with it the unease that we were not simply watching stone. We were watching something that knew how to reflect, something shaped in ways that recalled not chaos, but intention. Mars, the silent witness, recorded the glints again and again, and with every flash, the question of 3I Atlas grew sharper, as if the cosmos were signaling with mirrors across the void. Even as the flashes unsettled the optical teams, another stream of data arrived from MAVEN, the spacecraft orbiting Mars to study the tenuous breath of its atmosphere and its dance with the solar wind. Its sensors, tuned to ions and plasma flows, began reporting anomalies when 3I Atlas passed through the monitoring field. It should have been silent. An inert rock carries no plasma of its own. It only disturbs the solar wind as a stone disturbs a river. Yet MAVEN detected sudden flickers in ion density, spikes in charge exchange, and irregular currents that rippled like ghosts through the flow. These disturbances were localized in time, matching the predicted intervals when 3I Atlas crossed the observational line of sight. The signals were faint but undeniable. A sheath of ions seemed to cling to the object as though it carried its own plasma envelope. This was not the coma of a comet, not the sweeping tail of water vapor ionized by sunlight. It was thinner, subtler, more like the charged skin around a metallic body or a fragile membrane catching the solar wind. Scientists debated in long teleconferences. Was this simply dust micron-sized grains lofted and then electrified? Or had interstellar travel baked the surface into a conductor, leaving it prone to carrying charge? Some reached further. Could this be evidence of an ultra-thin sheet interacting with solar particles in ways rocks never could? What troubled them most was the coherence. Plasma noise is usually turbulent, chaotic, diffuse. This, by contrast, showed intervals of order periodic pulses, as though the sheath breathed. Mars, by accident of its orbit and MAVEN's instruments, had caught what Earth could not. The visitor wrapped not only in mystery of light, but in the electric whisper of plasma. It was as though 3I Atlas bore a veil invisible to the eye, but tangible to charged particles streaming past. A veil that did not belong to any known comet, and yet there it was, brushing against Mars's magnetotail like a silent signal from another star. While MAVEN traced whispers of plasma, the spectrometers aboard the ExoMars Trace Gas Orbiter turned their attention to the faint light streaming from 3I Atlas. Nomad and ACS, designed to unravel the chemistry of Mars's thin sky, were recalibrated to scan the alien body's spectrum. What they returned confounded expectation. A typical comet's fingerprint is familiar: strong water absorption bands, clear signals of carbon dioxide, traces of ammonia or methane, a choir of volatiles outgassed by sunlight. But in the data from Mars' orbit, those signatures were absent or distorted. Instead, faint, shifting bands appeared, bands that moved subtly from one observation to the next. At first glance, they resembled carbon-bearing molecules, but their strength and ratio did not align with known cometary chemistry. Some scientists proposed exotic ices, supervolatiles like nitrogen or carbon monoxide, frozen solid during eons of interstellar travel. Others saw the telltale hints of tholin-like substances, complex organics forged by cosmic radiation and ultraviolet light in deep space. These could explain the reddish tint Earth-based telescopes had seen earlier. Yet the Mars instruments revealed something stranger still. The features were unstable. In some passes, they flared strong. In others, they faded nearly to nothing. Such variability suggested more than surface frost. It hinted at layered materials, Skins of chemistry peeled back as the object tumbled, exposing different faces to the Sunday. The spectra became a patchwork diary of its composition, fragments of alien chemistry revealed only in flashes, then hidden again. The shifting bands unnerved theorists. If the object carried exotic organics, they were not distributed evenly, but in veins, crusts, or sheets. If it bore nitrogen or carbon monoxide ices, they were outgassing without producing the visible coma that would betray them. Each explanation clashed with another observation, leaving a net of contradictions. From Mars's silent orbit, the spectra whispered not of simplicity, but of a body layered in strangeness. Here was matter that had journeyed between stars, altered by radiation, fractured by time, carrying chemical signatures both familiar and alien. The instruments had spoken with precision, yet their message was confusion. What should have been a clear molecular fingerprint had become a shifting code, a cipher written by an object older than our Sunday. The flickering light curves, the sharp glints, the strange spectra these fragments invited reconstruction. Scientists turned to inversion modeling, feeding the brightness variations into algorithms that carve shadow into shape. From the raw data, a form began to emerge, not the spheroidal silhouette of an asteroid, nor the snowball geometry of a comet, but something elongated, improbable, fractured. The models implied an extreme aspect ratio, a body stretched thin, like a blade adrift in space. Some iterations suggested a length perhaps 10 times its width. Others revealed concavities, scooped depressions that caught and reflected sunlight in erratic flashes. The best fits hinted at facets angled like panels, scattering light in narrow beams. The shape was not smooth but jagged, a shard tumbling through the solar system. This was unsettling for two reasons. First, nature rarely shapes small bodies this way. Collisions grind fragments into rubble piles. Gravity rounds the larger ones. Sublimation sculpts comets into lumpy spheroids. Yet here was something resembling an engineered geometry. Long, flat planes, irregular cavities, sharp edges that gleamed like mirrors. Second, the tumbling was unstable. It rotated around multiple axes, a state known as non-principal axis rotation or tumbling chaos. Left unchecked, such motion should damp over time, settling into a stable spin. But the data suggested 3I Atlas had resisted that equilibrium, as though some internal rigidity preserved its strange dance. The more the models refined, the more the silhouette resembled not a stone but a relic, an object bearing surfaces, angles, shadows that teased at artificiality. Yet the scientists resisted. Nature is inventive, and the cosmos has sculpted weirder shapes. The contact binaries of Kuiper Belt worlds, the fractured shards of tidal debris. Still, the image held. A shard, a blade, a geometry of light and shadow, tumbling without peace. From Mars's vantage, inversion had turned flicker into form, and what the form revealed was not comfort, but a reminder. This visitor carried a shape too strange to dismiss, a geometry that unsettled both science and imagination. If the shape inversion startled astronomers, the thermal data unsettled them even more. Themis, the thermal emission imaging system orbiting Mars, traced how 3I Atlas absorbed and released heat as it turned beneath the Sunday. Here too, the visitor broke expectations. A rocky asteroid, compact and dense, warms slowly under sunlight and cools slowly when it turns away, a kind of thermal memory. Comets, layered with ice and dust, behave differently. They heat rapidly, their surfaces steaming with sublimation, and cool just as fast. But 3I Atlas refused either category. Its thermal inertia was inconsistent, caught in a paradox. In some measurements, it cooled far too quickly, like something porous, fragile, ultralight. In others, It retained warmth longer than dust or ice should, as though hidden layers or internal pockets resisted the cold. The data suggested a hybrid, a surface behaving like powdery ash, yet with the resilience of a rigid structure. Some scientists compared it to aerogel, a material both feather-light and strong, capable of baffling thermal transfer. Could nature build such a substance in the furnace of stars, then launch it across interstellar gulfs? Or was this a sign of fragmentation, an object already breaking apart, showing different faces with different properties as it tumbled? More troubling still was the absence of thermal spikes. If jets of gas were venting, Themis should have seen localized heating, bright points where sunlight cooked volatile patches into eruption. Instead, the heat patterns were smooth, global, unbroken by such scars. The acceleration observed earlier had no thermal signature to anchor it. The mismatch gnawed at theory. A body that cools like dust but endures like stone, that accelerates without jets, that carries glints without a coma. This was not the behavior of anything familiar. Mars had provided clarity, but clarity did not ease the mystery. It deepened it, layering paradox upon paradox, until the models bent beneath the contradictions. From orbit around the red planet, the silence of 3I Atlas became almost oppressive. It gave no tail, no heat scars, no clear answers, only riddles etched in temperature curves, riddles that suggested its substance was neither rock nor ice, but something stranger, something forged in conditions our solar system could scarcely imagine. The puzzle did not end with light curves or thermal maps. A deeper strangeness emerged in the polarization studies, those careful measurements of how sunlight scattered after striking the interstellar visitor. Polarimetry, though subtle, is a powerful diagnostic. Comets typically scatter light with predictable polarization curves, their dust grains aligning the phase angles into a familiar pattern. Asteroids, too, have their own signatures, their rocky regoliths scattering in ways catalogued across decades. But the readings from Mars refused these templates. As 3I Atlas rotated, its polarization angles shifted abruptly, breaking the smooth curves that physics predicted. At certain phases, light scattered in a manner so strong and directional that it suggested broad, flat reflectors, panels, or plates, with surfaces far smoother than any dusty regolith. At others, the polarization nearly collapsed, as though light was absorbed or redirected into depths invisible to the detectors. The inconsistency was its own message. For comets, polarization grows gently with phase angle, tracing the glow of fine dust. For asteroids, it bends in familiar arcs, dependent on grain size and porosity, and 3I Atlas obeyed neither. Its polarization law was broken. Some argued for interstellar weathering. Surfaces baked by cosmic rays could grow crusts of complex organics, scattering light in unusual ways. Others pointed to layered material, perhaps patches of frozen volatiles, alternating with fractured planes of rock. But the sharpness of the changes, the sudden swings in polarization angle, hinted at geometry, not randomness. Mars, with its vantage free from Earth's turbulent skies, offered resolution that ground-based telescopes could not match. Its detectors traced polarization phase curves cleanly, without atmospheric distortion. And what they traced was a visitor that did not scatter light like dust, did not reflect like stone, but seemed to carry facets that obeyed their own physics. The unease deepened. Polarization had been expected to provide reassurance, a scientific anchor, a way to classify the object by comparison to familiar bodies. Instead, it widened the gulf. Mars had revealed not a cometary law, not an asteroidal law, but something else, something between, or perhaps beyond. It was as if 3I Atlas whispered back through scattered light, "You do not know me." As 3I Atlas traced its path past Mars, the planet's invisible reach extended further than its thin atmosphere and dusty plains. Mars possesses a magnetotail, a long stretched veil of magnetic field and plasma, dragged outward by the solar wind. Though weaker and more fragile than Earth's magnetosphere, this tail stretches millions of kilometers, a faint curtain through which the interstellar visitor inevitably passed. When it did, MAVEN and other instruments registered distortions. The solar wind, normally smooth in its interaction with Mars, wavered as though encountering a foreign obstacle. Ion pickup signatures fluctuated, currents shifted, and faint echoes of field draping appeared, as though lines of magnetism had been bent around an object carrying its own tenuous sheath. For a body supposedly inert, the response was far too strong. To planetary scientists, this was a revelation. Most asteroids pass invisibly through such environments, too small and electrically quiet to leave a trace. Comets do interact, but only through their expansive comas, billowing clouds that couple with the wind. Yet 3I Atlas carried no coma. What, then, had wrapped itself in the Martian tail so forcefully? Some argued that interstellar weathering had charged its surface to an unusual degree, making it act like a giant capacitor in the solar wind. Others suspected a thin plasma envelope, perhaps the remnants of ancient interactions, clinging to its surface like static on a shard of glass. But the coherence of the signals, the way they arrived in structured, repeating bursts, hinted at something even stranger. The passage through Mars's magnetotail became a natural experiment, a cosmic test chamber that Earth could never provide. The red planet, silent and cold, had unwittingly exposed the visitor to a magnetic interrogation, and the visitor had answered with distortions that should not have been possible. For scientists watching from millions of kilometers away, the moment was sobering. 3I Atlas had not only defied optical and thermal expectations, it had written its presence into Mars's invisible fields. It was not just a body reflecting light, it was an active participant in the plasma sea, bending the lines of force as though it carried a hidden charge from the stars beyond. The enigma of 3I Atlas's path drew the attention of celestial mechanicians, those who live among numbers and equations, sculpting orbits with mathematics as painters shape light. Its trajectory, fitted and refitted with every new observation, refused to lie quietly inside Newton's classical frame. The deviations were small fractions of kilometers, seconds of arc, but persistent, insistent, undeniable. Here, relativity stepped in. For decades, Einstein's corrections have guided our spacecraft and our predictions. The sun's mass curves space-time, and the orbits of planets and comets precess ever so slightly under that curvature. For most objects, these post-Newtonian effects are too subtle to matter. But for 3I Atlas, threading the solar system at high velocity, even those quiet corrections became significant. Ephemerides were recalculated with Einstein's equations stitched into their heart. Solar radiation pressure was modeled with exquisite care. Every photon counted as a tiny push against the visitor's surface. Gravitational assists from Mars itself were weighed, however faint, and still the anomaly remained. Even with relativity folded into the fabric of prediction, the path was not what it should have been. The paradox echoed earlier puzzles. Oumuamua's gentle drift, Borisov's almost cometry but not quite nature. Once more, astronomers found themselves standing at the boundary between the calculable and the inexplicable. Relativity could refine, sharpen, adjust. It could not erase the deviation. To those who lived in numbers, this was disquieting. For if even Einstein's corrections could not fully reconcile the orbit, then what remained? A surface large enough to feel radiation like a sail, a geometry thin enough to warp the effect of photons? or some process not yet folded into the equations of celestial motion. Mars had offered the cleanest vantage, the richest data, and with it came the realization that our best mathematics, sharpened by a century of relativity, was not quite enough. The trajectory of 3I Atlas bent not only through space, but through theory itself. It was as if the universe, through this shard, reminded us that even the equations of Einstein whisper only part of the truth. As the discrepancies mounted, one hypothesis rose with renewed urgency: radiation pressure. The sun is not only light and warmth, it is a stream of momentum, photons striking every surface, imparting the faintest of thrusts. For most asteroids, compact and heavy, the push is negligible. But if an object were thin enough, light enough, broad enough, then sunlight itself could guide its path. This became the so-called radiation sail hypothesis. If 3I Atlas carried the density of rock, its acceleration was impossible. But if its effective density was hundreds, even thousands of times lower, like a sheet or a fractal lattice, then the anomaly dissolved into physics we already knew. Sunlight would be its engine, photons its propellant. From Mars's vantage, this seemed consistent with the glints, with the erratic brightness swings, with the absence of a coma. The idea painted a picture of an ultra-thin geometry, perhaps no thicker than foil, drifting across interstellar space for eons, surviving encounters with radiation and dust. The implications were twofold. On the one hand, nature might yet surprise us, capable of building vast, fragile structures through collisions or tidal shredding, leaving behind fragments stretched like sails. On the other, whispers emerged, if not natural, then engineered. A light sail is no stranger to human imagination. Concepts of photon sails, starships driven by pressure of starlight, have haunted the pages of scientific speculation for decades. Now the data seem to mimic those dreams. Most scientists resisted the leap. Extraordinary claims demanded extraordinary evidence, and the cosmos is a master of mimicry. Yet the elegance of the radiation sail hypothesis lingered. It explained without invention, required no new physics, only an object thinner than anything yet known to form naturally. Mars had given the model new weight. With every photon striking its surface, 3I Atlas seemed to lean into the sunlight, riding it as though it were wind. Was it coincidence or intention? The data could not decide. But the image held power, a shard of something vast, billowing invisibly before the star's eternal breath, a sail without a ship, gliding alone between suns. Yet radiation pressure alone could not silence all objections. Some scientists turned instead to the realm of exotic volatiles, substances so fragile that they could sublimate at temperatures too cold for earthly experience. In this scenario, 3I Atlas was no sail at all, but a shard wrapped in ices of carbon monoxide, carbon dioxide, or even molecular nitrogen. Unlike water ice, these super volatiles can vaporize in the chill of the outer solar system. A thin crust could mask their escape, allowing jets to seep invisibly, driving subtle thrust without the showy plumes of a comet. From Mars's orbit, such jets would be nearly undetectable, no broad coma, no dust tail, just faint accelerations written silently into the trajectory. This explanation carried a kind of comfort. It rooted the anomaly in chemistry rather than geometry, in the familiar, albeit extreme processes of sublimation. It aligned with what might be expected of a body born in another star's Kuiper belt, rich with ices lost by most solar comets. It even explained the shifting spectral lines seen by Nomad and ACS, the fleeting hints of carbon-bearing molecules. But problems lingered. Themis thermal data had shown no hotspots, no sudden rises in temperature where jets should have erupted. Maven's plasma spikes were irregular, not steady, inconsistent with sustained outgassing, and the variability of the acceleration seemed too smooth, too continuous, as though governed by surface area rather than venting. Still, the volatile hypothesis endured. It painted 3I Atlas, not as an engineered shard, nor a cosmic sail, but as a relic of alien formation, a remnant of distant ices sculpted in another star's nursery. Perhaps it was nature's own laboratory, carrying recipes of frozen chemistry unknown to our solar system. Perhaps the strangeness was not artifice, but the diversity of creation across the galaxy. From Mars, the evidence remained ambiguous, but the possibility lingered like frost, that the visitor's silence was not deliberate, but chemical, a slow evaporation too faint to see yet strong enough to bend its course across the Sunday, a ghost of volatiles, whispering propulsion into the void. Another picture soon entered the discussion, less exotic than light sails or hidden volatiles, but no less haunting. Perhaps 3I Atlas was not a coherent body at all, but a remnant, a fractured shard left behind by some violent encounter in the deep. Collisions are common in planetary nurseries. Asteroids collide, comets split, tidal forces from passing giants tear apart fragile bodies. In these crucibles, fragments are flung into space, some bound, some lost forever. Could 3I Atlas be one of these? A broken piece of a once larger world, stretched and sharpened by its violent birth, then set adrift for millions of years until it crossed our system. Mars's Lightcurve glints lent weight to this. Repeating flashes suggested large, flat facets, like the surfaces of a fractured plate. Tidal disruption could carve such planes, leaving thin, slab-like remnants. Laboratory impact experiments on Earth, when scaled to cosmic dimensions, produce shards with striking similarities, concavities, razor edges, reflective planes. A body like this would tumble chaotically, just as 3I Atlas seemed to do. But if fracture was the cause, the shard had survived far longer than models allowed. Interstellar space is harsh. Micrometeoroids, cosmic rays, thermal cycling. Fragile fragments should erode, crumble, vanish into dust long before reaching another star. Yet this one endured, long enough to find itself lit by the sun and gazed upon by Mars. Why? Was it unusually large for a shard, or had its composition been hardened by its passage? There was another unease too. Fractured shards usually produce a family, a trail of debris. Telescopes searched, but Mars saw no companions, no cloud of fragments strung along its path. It traveled alone, as though sculpted to solitude. The fractured shard scenario satisfied some of the contradictions. The planes, the glints, the tumbling chaos, but it birthed new ones. Survival against odds, isolation in the void, resilience that mocked fragility. If 3I Atlas was a shard, it was a shard that had outlived its kin, carrying with it a secret recipe for endurance across the gulfs between stars. If fracture explained the geometry, another theory spoke to the strange chemistry, interstellar weathering. Objects adrift beyond any star wander through a crucible invisible to human eyes. Cosmic rays, high-energy particles, and ultraviolet photons from countless suns hammer their surfaces for millions, even billions of years. What begins as rock or ice does not remain so. It is transfigured into something alien. Laboratory simulations on Earth offer glimpses of this process. Irradiated ices darken, redden, and polymerize into tar-like films. Hydrocarbons bond into tholins, complex organics that coat the surface in layers of brittle crust. Over time, these crusts scatter light differently than the materials beneath, bending polarization laws, reshaping spectral lines, creating the erratic features Mars's spectrometers recorded. 3. I Atlas may be sheathed in such a weathering skin, centimeters thick, maybe meters formed during its slow exile in interstellar night. The reddish hues seen by ground telescopes, the spectral hints of shifting organics, the strange scattering angles observed by Mars orbiters all aligned with the presence of a tholin-rich coat. But the theory raised unsettling questions. A weathered crust is brittle. Under solar heating, it should crack, spall, erupt in sheets of dust. Yet Mars's instruments found no coma, no stream of debris. Instead, the surface appeared intact, reflective in sharp glints, cooling and heating in ways that hinted at resilience rather than decay. Could interstellar weathering forge not fragility but strength, a protective armor? Or had the body already shed its outer layers, leaving only the hardened core? The plasma anomalies too found possible explanation here. Tholin crusts and carbonized layers can accumulate static, charging like capacitors in the solar wind. Such surfaces might interact with Mars's magnetotail in ways no ordinary rock would, leaving Maven to record disturbances more typical of an engineered conductor than a cometary relic. Through this lens, 3I Atlas became not a shard or a sail, but a survivor, an object sculpted by the galaxy itself, its skin a palimpsest of cosmic history. Mars had revealed the scars of weathering, but also its paradox, a body aged beyond imagining, yet still bright enough to glint, still stubborn enough to endure. As data accumulated, one element became increasingly clear: the object was not spinning in any stable way. Most small bodies, if left alone, settle into a principal axis rotation, like a balanced top. Energy dissipates, motion calms, and their light curves trace predictable rhythms. But 3I Atlas was different. Its brightness spikes, its erratic glints, its variable spectra all pointed toward a body locked in chaotic rotation, a tumble without equilibrium. This state is known as non-principal axis rotation. Astronomers sometimes call it tumbling chaos. It is not rare asteroids struck by impacts or comets venting gas can be thrown into such a state. But the chaos is not eternal. Over time, internal friction drains the energy, damping the wobble until stability returns. For kilometer-sized bodies, the timescale of damping is measured in thousands to millions of years, brief on cosmic terms. Yet 3I Atlas appeared to have carried its tumble for far longer across interstellar gulfs that should have silenced it. Mars's vantage made the instability undeniable. Light curves refused closure. Polarization angles shifted wildly. Thermal readings never repeated with precision. This was not a body whispering stability. It was a dancer stumbling endlessly, refusing rest. How could it have survived aeons without calming? Some proposed that its rigidity was extreme, that the material composing it, whether metallic or polymerized by cosmic radiation, resisted internal friction. Others suggested constant stimulation, micrometeoroid strikes, temperature cycling, or even interactions with the solar wind re-injecting energy, sustaining the chaos like a pendulum forever nudged. The philosophical unease was deeper. To astronomers, a tumbling body is a transitional state, a symptom of disturbance. To see one endure across interstellar travel is to face a paradox, an object both broken and preserved, restless yet eternal. In its endless spin, 3I Atlas seemed to embody contradiction itself. It was a relic that should have quieted, yet did not, a shard that should have crumbled, yet endured, a visitor whose rotation carried the memory of violence, still unreconciled, still unresolved. And in that unresolved motion lay a message, not in words but in movement. The cosmos does not promise calm, only persistence. Mars recorded this tumbling with merciless clarity, and in the irregular flicker of reflected light, humanity read both science and metaphor. 3I Atlas was not stable. It was not at peace. It was, and would remain in motion without rest. The riddles of light, heat, and motion converged upon one question: what could its emissivity tell us? Themis and supporting instruments measured the radiation, leaving 3I Atlas infrared whispers betraying how efficiently its surface shed absorbed energy. For most small bodies, emissivity is mundane, a constant folded neatly into thermal models. But here, the values slipped, skewed, resisted simple classification. At times, the object radiated heat as though it were dark, porous dust, shedding energy quickly into space. At others, its emissivity dropped, behaving more like smooth stone or even metal, reluctant to release what the sun had given. These contradictions echoed Hawking's musings on radiation and the stubbornness of information. How surfaces, whether black holes or alien shards, conceal their true nature in the way they emit. The data did not align with a homogeneous surface. Instead, it hinted at patchwork, regions alternating between high and low emissivity, fractured skins that glowed and dimmed unevenly. This explained some of the thermal mismatches Themis had tracked earlier. The body was not uniform but mosaic, a quilt of materials stitched by violence and time. For theorists, this carried both promise and peril. It suggested complexity, which was comforting. Nature often builds complexity from chaos. Yet it also suggested resilience, as if parts of the surface were hardened, resistant, unwilling to yield. Such surfaces could preserve the chaotic tumble indefinitely, dissipating little, betraying less. In this, some heard an echo of Hawking again. Information cannot simply vanish. It is encoded in emission, encrypted in radiation. Perhaps 3I Atlas too was encoded, its surface radiating truths in patterns too complex to decipher. Mars had recorded emissivity curves with precision, but what they revealed was more philosophical than physical. Here was an object that cooled and glowed in ways that refused simplification, as though reminding us that surfaces, whether cosmic or conceptual, are never just skins. They are boundaries between what is known and what is hidden. 3I Atlas radiated as though it carried secrets, and perhaps, in the stubborn variance of its emissivity, it did. With the object's paradoxes multiplying, attention turned to simulation. On Earth, in quiet labs filled with servers, researchers fed every scrap of data: light curves, spectra, plasma readings, emissivity maps into numerical engines. These simulations became mirrors, attempting to recreate what Mars had seen. At JPL, teams ran Monte Carlo campaigns, varying spin states, surface reflectivities, densities, and geometries by the thousands. In Europe, ESA researchers built thermal models layered with exotic ices, trying to replicate the erratic cooling patterns. Others simulated dustless comets, fractured shards, or sail-like sheets adrift in solar radiation. Some models came tantalizingly close. A thin, elongated shard with reflective facets, explained the Glints. A volatile rich crust could mimic the faint spectral bands. Plasma envelopes appeared in magneto-hydrodynamic codes if the body were porous and charged. Yet no single model captured all features at once. When brightness was explained, thermal inertia broke. When acceleration was matched, polarization laws collapsed. Every solution birthed a contradiction. The process became a race against time. 3I Atlas was already on its way out, its trajectory pulling it toward the dark, and the window of close observation was closing. Each night on Mars offered precious hours of data. Each day on Earth, a new round of simulations. The tension was palpable. Science had to catch the ghost before it vanished into interstellar silence. In the simulations, something else emerged, philosophical as much as physical. No matter how many models were tested, none was perfect. Nature, it seemed, had written an object so layered, so complex, that it resisted all simplification. It was a reminder of the limits of reduction, of the hubris in thinking every anomaly could be caged in equations. Mars had given humanity its clearest data yet. The simulations strained to keep pace, to hold the riddle in digital hands. But with each run, the scientists glimpsed another truth, that 3I Atlas might remain what it had always been, a cipher. Not because the models were wrong, but because the cosmos sometimes speaks in languages we are not yet ready to translate. For all the elegant models and high-fidelity simulations, a darker possibility haunted the researchers. What if the anomaly lay not in the object, but in the instruments themselves? Science, after all, has been deceived before. Phantom canals on Mars, false signals of life in noise, misreadings born of calibration error, all remind us that our machines are not flawless. And so began the painstaking hunt for ghosts within the data. Engineers examined high-rise frames pixel by pixel, searching for hot columns or cosmic ray strikes masquerading as glints. CTX exposures were reprocessed with alternate star field alignments, in case a background binary had been misidentified as a spike of light. Marcy's daily climate sweeps were checked against orbital geometry to ensure the object's path had not been confused with atmospheric streaks. Spectral anomalies from NOMAD and ACS were compared against calibration lamps to rule out shifting baselines or detector fatigue. The emissivity curves were tested against its performance on Martian soil to confirm no drift had crept into its readings. Even MAVEN's plasma signatures were scrutinized, cross-correlated with solar wind monitors, lest the disturbances be born of the sun rather than the visitor. The verdict was sobering. Artifacts existed. Yes, every instrument carries its scars, but none could explain the consistency of the signals. The glints repeated across cameras with different optics. The spectra shifted in ways unlinked to calibration. The plasma disturbances lined up precisely with predicted positions. Even the thermal contradictions held across instruments, across nights, across orbits. In this careful dismantling, paradox grew stronger. The data was not illusion. Mars's machines were not lying. What they saw, they truly saw. And if the instruments were innocent, then the mystery remained unsolved, pressed even harder against reality. For the scientists, this was a moment of both relief and dread. Relief that their machines had not failed them. Dread because the weight of explanation could no longer be deferred. If it was not error, then it was the universe itself. 3. Atlas was truly strange, and Mars had recorded its strangeness with merciless honesty. Even after instruments were cleared of suspicion, one final layer of inquiry emerged. Radio. Though no dedicated antenna had been pointed at 3I Atlas, the interstellar visitor left its fingerprints indirectly, embedded in the background static of spacecraft communications. Signals relayed between Mars orbiters and Earth-tight beams of radio stitched across millions of kilometers began to waver ever so slightly whenever their path brushed near the body's predicted position. It was not the clean silence of empty space. Subtle scintillations appeared, tiny fluctuations in phase and amplitude, as though the signal were passing through a veil of structured plasma. These disturbances resembled what astronomers sometimes detect when radio waves graze the ion tails of comets, yet no visible tail had been seen. The distortions were sharper, narrower, as though shaped by a sheath more compact and organized. Cross-checks with Earth-based radio observatories added weight, background quasars, steady beacons of deep space, flickered oddly when their light paths aligned with 3I Atlas's trajectory. The effect was faint but repeated. Something surrounded the object, something transparent to eyes yet opaque enough to nudge radio waves. Was it a plasma cocoon, ionized gases clinging stubbornly from interstellar passage, or a surface interaction charging itself against the solar wind. Some suggested a more speculative possibility, that the sheath was layered, structured, even filamentary, giving radio waves a lens-like path. The significance was profound. Optical instruments had shown glints, spectra, thermal contradictions. Plasma detectors had registered disturbances. Now radio itself, the most faithful of cosmic messengers, was whispering confirmation. 3. I Atlas carried an invisible environment, a halo not born of any ordinary comet. For the scientists, this convergence marked a turning point. 3 domains, light, particles, radio, each testified to the same truth. The object was not bare. It was wrapped in an unseen cloak, delicate yet real, bending the universe's signals as it passed. From Mars, the recordings were sparse, fragile, imperfect. Yet within their noise lived a pattern, and within that pattern, another question. If interstellar space could forge such an envelope, how many more travelers drift unseen, their halos bending radio, their whispers crossing the stars unnoticed? If the radio distortions hinted at a hidden envelope, the plasma data from MAVEN and the modeling of solar interactions provided a possible mechanism: magnetic drapery. When the solar wind meets an obstacle, whether a cometary coma, a planetary magnetosphere, or even a conducting surface, it bends, stretches, and folds its field lines around the intruder, like fabric caught on a pole. For most bodies, this process is straightforward. Comets drape the solar wind across their vast clouds of ionized gas. Mars itself, lacking a global magnetic field, shows draping as currents wrap around its ionosphere. But 3I Atlas carried no coma, no atmosphere, no magnetic dynamo. Still, the drapery appeared subtle but real, a distortion too coherent to ignore. The models suggested something radical. The object's surface might be ultralight, conductive, and extended, allowing solar particles to interact as though with a foil. In this view, the acceleration observed earlier was no mystery at all. Solar photons and solar particles were both pushing and shaping it, turning 3I Atlas into a canvas for the wind of the Sunday. A natural sail, perhaps, or something fractured into sheets so delicate they behaved like plasma-coupled membranes. This interpretation aligned uncomfortably with the radiation sail hypothesis. If the body interacted with light like a sail and with plasma like a conductive foil, then the distinction between rock and artifact blurred. Nature, perhaps, could forge such fragility from interstellar tides. Yet the symmetry of the interactions, their coherence, whispered of design. For observers on Earth and Mars, this was a moment of convergence. Optical, thermal, plasma, and now magnetic evidence all pointed to the same truth. 3I Atlas was not a compact boulder adrift in space. It was something wide, thin, responsive, a shape made to couple with the universe's invisible forces. Whether born of collision, chemistry, or something unimagined, the drapery revealed the visitor as more than inert matter. It was a participant in the cosmos, a partner of light and plasma, sailing not only through interstellar void, but upon the very fabric of fields that pervade it. Mars had seen not just a fragment, but a phenomenon, a shard that moved as though the solar system itself were its ocean. Night after night, Mars's instruments recorded the flicker of the interstellar shard. Each new pass tightened the uncertainties. Each additional frame refined the models. By the end of a week of coordinated observations, a pattern began to emerge, not perfect, not fully understood, but stubbornly consistent. The Lightcurves spikes, repeated at nearly the same rotational phases. The glints sharpened into recognizable sequences, like the beats of a pulse. Spectral bands shifted, but only within predictable ranges, as though tied to specific faces of the tumbling body. Even MAVEN's plasma anomalies began to recur in rhythm, hinting at a sheath that waxed and waned as the object turned. It was convergence without resolution. The data agreed that something systematic was at work, geometry, chemistry, or physics repeating itself in cycles, but none of the proposed models captured all facets at once. Each new explanation solved one part of the puzzle while breaking another. The radiation sail hypothesis fit the acceleration but failed the spectra. Exotic volatiles explained chemistry but not the glints. Shard fracture scenarios accounted for geometry but not for plasma behavior. Yet the repetition itself was a revelation. Nature rarely writes pure chaos. Beneath the surface mystery, there was structure and order that pointed to laws we did not yet know, or to materials untested in terrestrial labs. Mars had shown that the visitor was not random debris. It was something with coherence, a cipher written in brightness and shadow. For the scientists, this was both thrilling and humbling. To wrestle a pattern from the noise was victory. To admit that the pattern resisted decoding was an act of discipline. And in that tension between recognition and ignorance lay the beauty of science itself. As 3I Atlas receded further into the Martian sky, the nightly records became less about discovery and more about farewell. Yet within those last sequences, humanity had gained something precious, the knowledge that even in mystery, the universe repeats itself, whispering consistency through paradox. Mars had stared into the dark, and the dark had answered not with clarity, but with rhythm. When the nightly rhythms of 3I Atlas were finally catalogued, another conversation emerged, one not confined to the realm of astrophysics. Planetary defense specialists, long focused on near-Earth asteroids and comets, began to see Mars's vantage as more than a scientific gift. It was a rehearsal, an experiment in how two worlds could cooperate to watch the sky. From Earth alone, 3I Atlas had been a faint blur, its anomalies almost swallowed by distance and atmosphere. From Mars, the contradictions were undeniable. Together, the two planets offered stereo vision, depth perception across the solar system. It was proof that the most elusive objects could be cornered by triangulation, their secrets teased out by the geometry of worlds. The lesson reached beyond astronomy. If interstellar bodies arrive without warning, carrying strange trajectories or unknown substances, humanity's safety may one day depend on more than Earth-based eyes. A network of observatories scattered across planets, moons, and deep space stations could act as a planetary defense lattice, catching anomalies early, predicting impact risks with precision impossible from a single vantage. 3I Atlas became a case study. Papers circulated not just in scientific journals but in policy meetings. Mars had shown how a two-world system could work, how data could flow between agencies and continents, how silence in one sky could be answered by clarity in another. Engineers drafted proposals for relay constellations, small telescopes stationed around Mars and the Moon, a distributed early warning system for cosmic visitors. The paradox was not lost on anyone. An object that had defied classification, that had resisted every model, had nonetheless taught something practical: how to prepare for the next. Its mystery seeded infrastructure. Its silence provoked planning. Mars's witness to 3I Atlas was not only a triumph of science, but a sketch of future defense. The red planet had become, for a brief moment, not just an observer, but a sentinel. And, in its patient gaze, humanity glimpsed a new strategy: to watch the universe together, across worlds, as if the solar system itself were one great observatory. Even as planetary defense circles absorbed the lesson, mission designers began to dream further. If Mars had acted as an observatory, why not go beyond watching? Why not chase? Why not meet the next interstellar visitor, not with cameras from afar, but with instruments in hand? The idea was not new. Concepts of interstellar interceptors, had circulated since Oumuamua. Small probes, lightweight and fast, could be launched on standby, waiting in storage or orbit until a target was detected. At the alarm, they would ignite and pursue, racing to intercept while the object still lingered within reach. But until 3I Atlas, such visions had felt speculative, almost indulgent. Mars's revelations turned speculation into urgency. Engineers sketched designs, CubeSats riding on larger missions, able to peel off at short notice, solar sails that could be unfurled and steered toward a new trajectory in weeks, ion drives powered by compact reactors capable of adjusting course mid-chase. Even piggyback concepts were revived, attaching interceptor pods to routine launches, silent passengers waiting for the call to leap. Each design confronted the same challenge: speed. Interstellar visitors arrive unbound, fast as freedom, slingshotting past the sun in months. To catch them, missions must launch almost instantly. That required readiness, not planning. Infrastructure would need to be permanent, poised. 3I Atlas became the justification. Its anomalies were too rich, too fleeting, too frustrating to watch vanish into the void. Never again, the voices argued, should humanity let such a messenger slip away without a direct encounter. Proposals were written with renewed conviction: NASA's interstellar probe concepts, ESA's comet interceptor frameworks, private initiatives for solar sailcraft all found fuel in the mystery Mars had unveiled. The paradox sharpened into resolve. 3I Atlas had left more questions than answers, but in those unanswered questions lived momentum, a drive to be ready for the next. Mars had taught us to watch as a sentinel. The next step would be bolder, to leap from watching to reaching, to close the gulf not with pixels but with presence. Beyond the urgency of intercept missions, astronomers turned their eyes toward the near future, to a project already nearing completion on Earth, the Vera C. Rubin Observatory, with its large synoptic survey telescope. Where Mars had given a rare second vantage, Rubin promised something else: a flood of detections, a night-by-night inventory of the dynamic sky. The LSST was built to sweep the heavens every few nights, cataloguing changes with relentless cadence. Supernovae, variable stars, asteroids, comets, all would fall into its archive, and among them, inevitably, would be more interstellar visitors. The telescope's sensitivity and coverage meant that objects like 3I Atlas would no longer slip by unnoticed. They would be tracked earlier, more precisely, their orbits refined while there was still time to act. For planetary defense, Rubin meant foresight. For interstellar science, it meant abundance. Instead of a handful of enigmas, Oumuamua, Borisov, Atlas, there might be dozens, even hundreds, over decades. Each would carry the chemistry of alien nurseries, the scars of interstellar weathering, the secrets of distant collisions. Each would be another chance to confront the strangeness that Mars had glimpsed but could not resolve. Yet even here, Mars's role lingered. Data from two worlds could do what one could not: triangulate, refine, confirm. In proposals drafted after 3I Atlas, astronomers argued that Earth-based surveys should be paired with Mars-based observatories, perhaps small telescopes orbiting the red planet or perched on its moons. Rubin would cast the net wide. Mars would tighten it. Together, they would transform fleeting visitors into studied subjects. The promise of Rubin was staggering: a universe not of silence but of encounters, a solar system crisscrossed by the debris of other stars. And the lesson of 3I Atlas was clear: each visitor is a riddle, too complex for a single vantage to solve. The next time, with Rubin's early warnings and Mars's clear skies, humanity might be ready not only to watch, but to understand. In that vision lay hope that the mystery glimpsed in this one shard was not an exception, but the beginning of a dialogue. The cosmos had sent a fragment, Soon, we would be prepared to listen more deeply, with eyes from more than one world. As the weeks passed and the data streams slowed, scientists began to step back from the torrents of numbers. They asked not only what they had seen, but what it meant. The images from Mars, stripped of illusion, still whispered of a body that did not fit the molds of comet or asteroid. Its brightness curves, its spectral hints, its plasma cloak each had resisted tidy classification. The final composites of the Mars campaign showed a shard-shaped visitor, tumbling endlessly, reflecting light in flashes too sharp for randomness. Its surface chemistry was patchwork, bearing scars of radiation and traces of exotic organics. Its acceleration spoke of forces too delicate for eyes to see, yet too strong to ignore. Mars's magnetotail had felt its presence. Radio waves had bent as they passed it. Every domain of measurement had been touched, every instrument unsettled. Yet through all this, the object never broke its silence. No tail unfurled, no fragments peeled away. It did not betray itself in jets or dust. Instead, it slipped through the solar system like a cipher, carrying structure, motion, and mystery, but not confession. What did the images whisper? That matter can be arranged in ways we have not yet imagined, that the galaxy forges relics stranger than our textbooks dare to describe, that perhaps, scattered among the stars, are countless such shards broken, weathered, or perhaps designed passing silently from system to system, unnoticed until geometry and vigilance align. For the scientists who had witnessed it, 3I Atlas became less a single event than a symbol. It stood for the limits of classification, the humility of not knowing. It reminded them that data is not always closure, that sometimes the universe gives only fragments, glimpses, provocations. Mars had given humanity its clearest look yet at an interstellar visitor, and in that clarity, paradox deepened. The images whispered, not certainty, but wonder. As 3I Atlas drifted beyond Mars's reach, the object began to fade into the anonymity of distance. Its light curves softened into noise, its spectral features blurred into the background of stars. The great campaign that had mobilized 2 planets gradually fell silent, not because the mystery was solved, but because the visitor had outrun our instruments. Yet in the stillness that followed, a strange calm settled over the scientific community. They had not unlocked the secret of 3I Atlas. They had not classified it neatly, nor resolved every contradiction. But they had seen, with unprecedented clarity, that the cosmos can still defy us. They had proven that worlds can work together, Earth and Mars, separated by millions of kilometers, united in purpose to watch the unknown pass close enough to touch with light. And in that act, something shifted. The visitor had become more than data. It had become a mirror. In its glints and silences, its plasma whispers and tumbling chaos, it reflected back the truth of our place. Small beings with fragile machines, peering outward with hunger, asking questions larger than ourselves. When the final images were archived, the scientists lingered on them not as failures, but as reminders. A shard from another star had passed us by, inscrutable, serene, indifferent. Yet it had left us changed. It had forced us to rethink our tools, our models, our assumptions. It had shown us that the boundary between natural and unnatural, between fragment and artifact, between random and intentional, is far thinner than we imagine. Mars had watched in silence, and in that silence, humanity discovered both its limits and its courage. The interstellar visitor moved on, but the questions it raised remained, echoing through observatories, through classrooms, through the dreams of those who stared into the night sky. The cosmos had spoken in riddles, and though we could not yet solve them, we listened. That, perhaps, was enough. And now, as the interstellar shard fades into the black, let us slow our gaze. Imagine the object vanishing into the starfields, its glints no longer sharp, its secrets dissolving into distance. The silence of space enfolds it, and with each passing hour, it becomes less a riddle to solve than a memory to hold. In the hush that follows, we can feel the measure of perspective, our instruments strained, our theories stretched, and yet what remains is not failure, but wonder. To watch from two worlds, to record light that has travelled across both interstellar void and Martian orbit, is to touch the edge of something vast. And in that touch, humanity is reminded of its place small, questioning, hopeful. The cosmos does not rush to answer us. Its riddles are not written for quick resolution. They are carved in silence, carried on bodies like 3-eye Atlas, left for us to encounter only in fleeting glimpses. And perhaps that is enough. Perhaps the purpose is not in solving every anomaly, but in learning how to look, how to listen, how to wonder together. So let the visitor drift back into the unknown, its plasma cloak and tumbling shards disappearing into the tapestry of stars. Let the questions it raised linger gently, not as burdens, but as invitations to build better eyes, to keep watch from more than one world, to never stop asking. The night is wide and the sky is deep. As you rest now, imagine Mars still turning in its silence, carrying orbiters that remember, carrying data that endures. Somewhere, 3-eye Atlas sails on, indifferent yet beautiful, leaving us with mystery, leaving us with wonder, leaving us with dreams. Sweet dreams,